Welcome to The Explainer! Today, we're going to follow the absolutely incredible high-speed journey that happens every single time you click on a website.
I mean, it feels totally instant, doesn't it? You hit enter and boom, there's the page. But behind that simple action is this fascinating chain of events, a hidden conversation between computers happening at pretty much the speed of light.
All right, let's dive right in. To get this, first we need to understand the instruction you're actually giving your computer when you type in a web address. You see, your browser doesn't just see a line of text. No, it sees a set of instructions. It breaks that URL into three key parts: the protocol, which is kind of like the language or the rules for the conversation, the domain name, which is obviously the destination, and then the specific path to the exact piece of information it needs to ask for.
But before your request can shoot across the globe, it has to start its journey much closer to home, right there in your local network.
So, the whole thing begins with your computer, which in network speak we call a node. On its own, it's totally isolated. To talk to anything, it has to connect to other devices.
And that is the router's job. Its whole purpose is to connect all your local gadgets, your computer, your phone, that smart TV, and create what we call a local area network, or LAN for short. It's basically the central traffic controller for your home's digital world.
Now, for any of these devices to actually talk to each other, they need addresses. It's just like sending a postcard, right? You need a specific house on a specific street. Well, in the digital world, that unique identifier is called an IP address.
Okay, and this is a really key concept to grasp. Your network is actually using two kinds of addresses. Your devices have private local IP addresses just to talk amongst themselves inside your house. But when your entire network needs to talk to the outside world, it uses a single public IP address given to you by your internet service provider.
So your router knows how to get out onto the internet, but how on earth does it find the specific server for, say, example.com out of literally billions of computers out there?
Well, the answer is the Domain Name System, or DNS. The best way to think of it is as a massive globe-spanning phone book for the entire internet. Its whole job is to translate the domain names we can remember into the numerical IP addresses that computers actually need to use.
And to be super efficient, your computer first checks its own memory, its cache, to see if it's been to this website recently. If it hasn't, it kicks off this chain reaction, asking a series of special servers, where each one gets it a step closer to finding the correct IP address for the site you want. Okay, with the server's IP address finally found, your browser can now reach out across the internet and set up a direct, reliable connection. And this happens through a really elegant little process called the TCP three-way handshake. It's basically a quick, polite digital greeting. It makes sure both sides are online, they're listening, and they're ready to talk reliably before any of the real data gets sent. Now that we've got an open connection, the actual data, your request for the web page, needs to be packaged up and sent out according to a very specific set of rules. This whole thing is governed by what's called a protocol stack. Honestly, the best way to think about it is like the shipping and handling department of the internet, where every single layer has one very specific job to do. So right at the top, you have the application layer. This is the actual content of your package, the HTTP request to get me this web page. Then the transport layer, using TCP, is all about reliable delivery. It makes sure all the pieces of data arrive, they arrive in the right order, and they get to the correct application, like your web browser, not your email client. Below that, the network layer acts like the GPS for the entire journey. It's what uses those IP addresses we found to route the data across all the different networks between your home and that server.
The data link layer handles the local, hop-by-hop delivery. Think of it as the step from your computer just to your router. For this, it uses physical hardware addresses, which are called MAC addresses.
And finally, we get down to the physical layer. This is the actual hardware. You know, the roads and the trucks. The Ethernet cables, the fiber optics, the Wi-Fi signals, all the stuff that actually transmits the ones and zeros as little pulses of electricity or light. You know, this slide clears up a really common point of confusion, the difference between a switch and a router. A switch works at layer 2. It's like a local mail sorter, just directing traffic within your home network using those physical MAC addresses. A router, on the other hand, works at layer 3. It's like the main post office, using IP addresses to connect your network to all the other networks out there in the world. So, after the server gets your request, processes it, and sends a response all the way back along that same path, your browser finally receives the data and can get to work. And there it is. That's the whole incredible journey. Your simple click makes your browser find an IP address, do a digital handshake to create a secure connection, send out a request, and get raw code back. Then, your browser plays master architect, assembling all that code into the visual, interactive web page that you see on your screen.
And just think, every single step of that process happens in just a few milliseconds. It is a hidden symphony of protocols and hardware, all working in perfect harmony to make our digital world possible. It really makes you wonder, doesn't it? What other simple things that we do every day are secretly this complex?